Hello and welcome back to our channel. Today I would like us to look into Kirchoff's current and voltage laws. There is a problem involving solving this problem using those two laws. And without much time, the question that we are provided from that diagram is determine the current I1, I2 and I3 passing through the 10 ohm, 3 ohm and 5 ohm resistors respectively. So we are going to be applying the Kirchoff's current and voltage laws simultaneously so that we can be in a position to determine what the question requires from us. And for you to be in a position to apply the Kirchoff's current and voltage law from this circuit diagram, you need first of all to be in a position to know what are loops and determine how many loops we have from this diagram. From our diagram, as you can see, we have got two loops. We have got this first loop and this second one. Now, having that in mind, we can say let this direction of current be that one and this other one be going to that direction as indicated. After that, then we can begin by saying now from KCL, or rather the Kirchoff's current law, if you try and check into our diagram, we have got I1 here, I2 and I3. And from the definition of the Kirchoff's current law, if you apply the definition of the law, you will find that this current passing here is equals to the current that branches to this direction and the remainder passes through this other direction. So from that, we can say that I1 is equals to I2 plus I3. We can let that one be our equation 1. Then we can first shift to now the Kirchoff's voltage law and say KVL, the difference between these two voltages, the 9 and the 3. So we can say 9 minus 3, it will be the second now, the application of now the KVL. It will be now minus, now using this first loop, or rather this loop passing through this point, it can be this at this resistor. So at that resistor we can say 10 I1, then plus 3 I2. Where are these 10 I1, 3 I2 coming from? You know that from Ohm's law, V is equals to IR. So voltage, remember we are dealing with Kirchoff's voltage law. So we are dealing with voltage, and voltage from Ohm's law we know is given by current times resistance. For this resistor here, it has a resistance of 10 and the current that is passing through it is I1. The same to this case. So that is where we are getting 10I plus 3I2. Then simplify this one, you will get 6, that is 9 minus 3, you get 6 is equals to 10I1 plus 3I2. Then that one, we can let it be our equation 2. Also, and now for the second, the other loop, we can say, also using the same KVL, we can say 3 plus 3i2, that one should give us 5i3 from the diagram. That is from the diagram, because you know this 3 is this one, plus this 3 also from Ohm's law, 3i2 is equals to 5i3. That is the second loop. Then you can take these group like terms together, so that we have 3 is equals to 5 i3 minus 3i2, and we can say, so that now this one we can let it be our equation 3. Then we can say from equation 1, because now we are done with the loops, we are done with now the loops. So from equation 1 we can say make like i3, we can say i3 is just making i3 the subject, so that we take this i2 to the other side, so that we'll have is equals to i1 minus i2. This one we can let it be our equation 4. And now having that, equation 3 becomes 3 is equals to 5. Now instead of writing i3, remember we have said i3 is equals to i1 minus i2. So that will just substitute, and the equation will be i1 minus i2 minus 3i2. So that now, then 5 is just opening up that brackets, 5i1 minus 8i2. This one should give us what? 3. And the reason is just we have opened up the brackets, 5i1, this one, then 5i2 minus 3i2. We have i2, they are like terms, so that we get 8i2 is equals to 3. And making like we make i2 want to form an equation that has i2, so that i2 will be given by 5i1 minus 3. Remember here we had 8. Instead of now, we can just include 8, so divide both sides by 8. Also here by 8. This one cancel.